there are 3 squares in between each number. So all we had to do was take 30,000 in between each of these and divide it by 3 because that's how many squares there are, and we got 10,000. Yeah.
And overall, the scale goes up by what?
30,000. Besides this point, it went up by 60,000.
And after 120,000, did it continue going up by 30,000?
120. Yes.
Okay, so ideally, it would not do that,
No.
right? Okay, did you guys add that jagged line?
No, we didn't have that.
So did this group add that jagged line after yesterday's lesson about the jagged line? Okay. Okay, so if we can ignore that for a moment, because you would only use the jagged line between 0 and the first number. So I'm going to infer that it wasn't deliberate in the first place, that it was just a mistake, which is okay. It's a small mistake overall. We can see that the scale does make sense. Okay, and could I ask, Stu, would you say that this graph looks more like the textbook examples, more like Emily's graph or more like Carla's graph?
Carlos graph?
Right. In what way is it more like Carla's graph?
Because everything looks bigger.
Right? Everything looks bigger. And anyone can answer this question. How do we make, and Stu, you could answer it too if you want, or Miles, or anyone, how does someone do that? How does someone make the data look bigger? Miles?
If they if they make these two numbers closer together, you have to make this bar go up further, making it appear larger, even though it's not.
Excellent. Okay. And so the overall impression of this kind of a stretched out scale, the overall impression tells us what about import cars to Canada? What impression does this graph give us? Ryan?
They have grown bigger, like higher and higher, and increased really high between 1995 and 2002.
Super. Thanks, everyone.